can start. First of all, thank everybody for coming. This presentation we're going to speak about the new features in ProxySQL 2.0. Quick question, who is using 2.0 right now? Or anybody using 2.0? 1.4? Okay, so quick quick slide about who we are. We basically are developing ProxySQL as a product, and we also provide DBRD consultancy, and we also provide support for the same product. Here is a list of few companies that are using ProxySQL. This list is actually a bit old, so the list of companies that are currently using ProxySQL is growing on a daily basis. Other things is we're currently hiring. We are especially looking for some C++ developer with knowledge of MySQL. So if you know somebody, just let us know. Okay, who I am? I'm founder of ProxySQL itself, and I'm the author of ProxySQL, and my background is as a MySQL DBA for quite a long time, something like 15 years. So yeah, I've been in the industry for quite long. Okay, so this presentation is about the new feature in ProxySQL 2.0, and these are basically the topics that we are going to cover. So, which are the new packaging that are available in 2.0, and what has changed in the way the query cache works, the introduction of GTID consistent read, the new support for Galera, support for Aurora, and we also have integration with LDAP. This is a feature that was asked for quite a long time. And then we have also improved security. Specifically, we have SSL implemented also for front end. We have the Audit Log in 2.05, and we also have introduced support for JSON and several performance improvements that we are going to cover later, and also finally ProxySQL 2.0 works with MySQL 8. 1.4 doesn't work with MySQL 8. Okay, so first topic is which OS we support and how the packaging has changed. So first of all, we discontinued the support for Red Hat and CentOS 5. And same for Debian 7 and Ubuntu 12. The reason why we discontinued that is that just the code that we are running there, it doesn't compile anymore because we're using new dialect that basically won't compile there anymore. And instead we have introduced support for Ubuntu 18 and Fedora 27 and 28. Also, with regard to the packaging, we are now running using systemd, while until 1.4 systemd was not supported. Currently, systemd is only for Ubuntu and Debian, and but we almost have ready also the support for Red Hat. And another important change is that now ProxySQL runs with his own users, that is ProxySQL itself, and not anymore as root as in the previous version. That's quite important if you are creating from a previous version, because if you are creating and you have old files that are owned by root, then the process is likely to fail to start because the old files have different content. So this is something to keep in mind if you are upgrading. So the packaging now is, the build process is using local compose, and it's using some Docker images that are available on this repository, and we also have all those packages that are available in Docker Hub, and and you can basically use ProxySQL as a container directly from Docker Hub. So we also have our own repository. We avoid having ProxySQL 1.4 and ProxySQL 2 on the same repository path, so to avoid automatically upgrade if you have configured your system to have automatically upgrade. So we're just using a different path. So we avoid this to happen. Yes, and basically, again, we are supporting both APT repository and YAML repository. Query cache. As I was mentioning before, some improvement has been done on the way the query cache works. Specifically, what we have done is we introduced a new command that is able to completely flash the query cache. And before this was not possible, while now we can run ProxySQL flash query cache and we basically remove everything from the query cache. And another way of updating the query cache, while in 1.4 you had just to wait for the cache entry to expire, in 2.0 what you can do is you change the cache TTL in MySQL query rules to a different value, and then this value is the one that will be determined to identify when the entry has to be expired. So basically, if you had a cache TTL of several minutes, and then in 1.4 you change it to a few seconds, and the entry in the cache will still expire in a few minutes, while in 2.0 it will expire in a couple of seconds, because this is the new value you introduced. Also, we have introduced another columns in the MySQL query rules, that is cache empty result. If this is set to 1, that is the default, basically the query cache is also caching empty result set, while if it's set to 0, it will cache only results set that are not empty. This was a specific request from one of our customers, that he basically want the query cache to cache result only if there is result set. The specific case was that he was querying the database, and if the database, the first query maybe was not returning any data, so basically he didn't want empty result set to be cached until a select statement was actually returning data. Only at that point the result set has to be cached. I don't know who is familiar with this table. Start MySQL query digest is basically a view inside the proxy that allows you to have information about all the queries that have been executed, and they are grouped by username and by schema, host group, and so on. And we introduced new columns here, and that is basically also able to track the source IP of the client that has issued this query. And to enable this, you have to introduce this. You have to enable this variable, MySQL query digest hostname. By default, it's disabled, so it keeps the same behavior 1.4. And if you enable it, it will also track the hostname, but it also has the disadvantage of having a larger table, because now this table will have a different row per client IP. So, of course, if you have many clients that are using the same proxy, this table will grow by the number of clients you have. So, GTID, causal read, anybody is familiar with this? This was presented a few times in the past. So basically, what it allows is to have MySQL. So basically, what happened is that ProxySQL is able to use the GTID that MySQL itself is returning as part of the MySQL protocol in the K package, and thanks to this, is able to provide consistent read as well specifically. Of course, you have to enable the GTID in MySQL Server, and you configure MySQL Server to return the GTID in the K package. And every time you are executing a transaction as part of the commit, or a simple DML statement if you are running out of commit mode, the MySQL Server will return an OK packet that ProxySQL is able to track. So based on this, it will then be able to execute to know on which replica that GTID was already executed. Things becomes more clear with the picture. So here it is. So basically the way it works is, so we have those proxy that are executing query on this server, that is a MySQL master. Then the MySQL master return an OK packet to the ProxySQL. And as part of the OK packet is also returned the GTID. Now, as part of the replication, the replication event goes to all the slaves. The slaves will get this replication event, will execute it, and they will write the event in their own binary log. Now we have those process, that is a new process created for ProxySQL, that is a process that is streaming the binary log from every server. It basically works as a server to connect using MySQL application. It's getting all the Binlog event and stripping out everything with the exception of the GTID. And now those GTID are sent back to every ProxySQL. So if the client executes a YAML statement here or execute a transaction, the transaction is executed on the master, replicated on the state, and this proxy knows exactly when the transaction was executed on every slave. So if the client then executes a select statement, basically it's executing a read, ProxySQL is able to ensure that the read is sent to one of the slaves, and the slave is in sync with the master with regard to that specific statement.
So this is an implementation basically of read your own writes.
That's correct.
Could we also do something like we read from a slave, and then we read from another slave later, and we want to avoid the second read to be in the past. So we only want to move our read view forward. So could we use this or a variation of this to avoid going back in the past? So I don't know if on a select we are able to get the GTID of a slave and then read from another slave that is further.
Well, we don't need the GTID from the select because what we need to know is the GTID at a specific moment in the slave. So this information is there, but it's not coming from the select statement. What you're asking is not implemented, but it's absolutely something.
It's something that we could do variation.
All the pieces are there. Just the logic needs to be implemented. Remind me later because otherwise I will forget. This process is extremely lightweight because it is basically just reading the binary log and stripping out everything with the exception of the GTID. So this works completely real time, so it's quite fast. This process is currently not part of ProxySQL itself, so it's not packaged together, but you can get it on GitHub. There is another repository.
Sorry, René, and what happens if none of the slaves have already reached their GTID?
So here you have also the master itself. The master itself has the same process. So the master sent to ProxySQL also his own GTID. So when a client comes and executes a query, when the same client executes a select statement, and the select statement needs to be sent to one of the leaders, ProxySQL will know immediately if the slaves are in sync, and if they're not, we will send traffic to the master.
Thank you.
Okay, so I was saying that it's extremely lightweight. It's also able to auto-restart, so it has the same restart features of ProxySQL. So if for whatever reason it's being killed, we just restart. It is available on GitHub right now. This is the URL of the repository. Currently, from this repository itself, if you run make Ubuntu 18, it will automatically generate the package for Ubuntu 18. This is currently the only platform we are compiling it, but nothing stops you for compiling also on CentOS or any other system. Okay. Now, we introduce also a deep support for Galera. Quick introduction, I'm pretty sure that everybody knows what Galera is. So I'll probably just skip this slide. So move to master setup. If you have used MySQL 1, ProxySQL 1.4, you know that there was also support for group replication. Group replication was done using a table called MySQL group replication, in which group replication Hostgroups. And there is also a table called MySQL Hostgroup replication, that basically where you find the reader host group and the writer host group. This was extended for group replication, having also some more parameters like the maximum number of writer, if the writer should also be a reader. Then for group replication it was max transaction behind. Basically, if one of the server was behind the writer by a certain number of transactions, it was taken out from the cluster at ProxySQL level, at the group replication level. And then there were also two more host groups. That it was the backup writer host group, that is basically a host group where all the writers were placed if the number of writers was greater than the maximum number of writers defined. And then the offline host group where all the servers unhealthy were moved there for whatever reason, if they're doing maintenance or just because one of the servers died. They were automatically moved into the offline host group. So the same table structure was basically used for Galera. So we have this table called MySQL Galera host group, where basically it is the columns that I was explaining before. So you have the writer host group, the backup writer host group, the reader host group, offline host group, active. So you can also define if one specific host group set is active or not. The maximum number of writers is also readers, and max transaction behind. This is actually not correct as the name because we just use the same name that we were using for group replication, but here in reality what it defines is the maximum number of writes that were not applied yet. Here is basically described what I just said. Okay. Now also globally for Galera Cluster, we also have a certain number of global variables that define how frequently health check is being performed on every server, and these variables, MySQL monitor Galera health check interval. So this means that by default, every 5 seconds, every server is checked to verify that it's healthy and is the state of the server. Every check has also a timeout. So in this case, the timeout for those checks is 800 milliseconds. So if a check fails after 800 milliseconds, it means that the server is unhealthy. Nonetheless, if a server is unhealthy, it's not removed from the cluster immediately, but it will wait up to 3 failure consecutive timeouts before removing the server. Of course, if the checks clearly fails, like if the server is down, the server is removed immediately, but if the checks is timing out, it has to time out 3 times before removing the server. This specific variable that I just mentioned was introduced extremely recently into 0.4. Okay. This was specifically introduced to avoid scenarios in which one check was just failing, so the server was constantly removed and took back. For example, if there was a temporary network glitch or the server was slightly overloaded, so the check was just timing out instead of the server being actually down. Okay, now into 2.0, we are also adding support for Aurora. It's not completed, it's almost done. We're just waiting some customers to finish their testing to actually proceed with to finish the development of this of Aurora, of the Aurora implementation. So the way it works is there are a few features that are introduced specifically for Aurora. Specifically, it gets information about Aurora from this table, that is a table that Aurora provides to get the status of the cluster. This is the replica host status. So the advantage of here is that ProxySQL doesn't need to figure out which one is the writer and which one is the reader, or which are the healthy node and which are not. But it's Aurora itself that is telling ProxySQL which one they are. So ProxySQL has only to read this table from any of the nodes and figure out what is the status of the cluster. So it automatically is able to detect which one is the writer and which one are the reader. And the fact that this reading this table introduces other advantages. Specifically, it is able to perform auto-discovery. So if you have a cluster, Aurora cluster of 3 nodes, and then you switch to 4 nodes, you don't need to configure ProxySQL. There is a 4th node that was introduced, but ProxySQL is able to identify it because it has just to read this information from this table. Also, it becomes AZ aware, so it's able to identify which is the latency of every node in Aurora cluster, and this has great advantages if you want to read from a replica that is on the same AZ. So you basically reduce a lot the network round trip to reach any of the replicas because you are already communicating with the local replica. So the latency is way smaller, and of course you also have some economic benefit because you are removing the cost associated with cross-AZ network traffic. Also, it is able to perform reading from this table is also able to identify what is the replication log of every replica in Aurora, and is able to monitor replication log with millisecond granularity. This again was a requirement from one of our customers that specifically wanted to not read from replicas if they are lagging more than 20 milliseconds. Okay. This is the table basically. As you can see here, the table structure looks quite similar to the one of Galera. It is similar to the one of Aurora. Sorry, of the one of group replication. So you have the writer host group, reader host group. You don't have anymore the offline one because it's not needed anymore. You have the active. With regard to Aurora, because there is auto discovery and basically all the server has on the same port, after on the same port, you also have the port specified in this table. So when your server is detected, the host name is detected automatically and the port is taken from this table. The endpoint address. So this table doesn't give the full name of the host, but only the initial part of the host name. So the endpoint address is normally added to the host name, so it's able to create the full host name. Then you have maximum lagging millisecond. So any server that is lagging for more than this number of milliseconds is automatically disabled, so no read is being sent to it. The default is quite large. The default is like 10 minutes, but in reality you can lower it to up to 10 milliseconds. Then you also have the check interval in millisecond. Again, it basically says how frequently the interval the check needs to be performed. By default is 1 second, but you can lower it down up to 100 milliseconds. And then you probably have to tune also the check timeout. Again, by default is quite high, but if you want to have these features to read, to send traffic to a reader only, the replication lag is very small, you have to basically lower a lot the check interval millisecond and the check timeout millisecond. So basically, you are checking the status of every replica very frequently. Also, you have writer is also reader. So basically what this means is that when a failover happened, if the replica that now has become the new writer, it has also to process save statement or not. And now those GTID are sent back to every ProxySQL. So if the client executes a YAML statement here or execute a transaction, the transaction is executed on the master, replicated on the state, and this proxy knows exactly when the transaction was executed on every slaves. So if the client then execute a select statement, basically it's executing a read, ProxySQL is able to ensure that the read is sent to one of the slaves, and the slaves is in sync with the master with regard to that specific statement.
So this is an implementation basically of read your own rights.
That's correct.
Could we also do something like we read from a slave, and then we read from another slave later, and we want to avoid the second read to be in the past. So we only want to move our read view forward. So could we use this or a variation of this to avoid going back in the past? So I don't know if on a select we are able to get the GTID of a slave and then read from another slave that is further.
Well, we don't need the GTID from the select, because what we need to know is the GTID at a specific moment in the slave. So this information is there, but it is not coming from the select statement. What you're asking is not implemented, but is absolutely something.
It's something that we could do a variation.
All the pieces are there. Just the logic needs to be implemented. Remind me later, because otherwise I will forget. This process is extremely lightweight, because it is basically just reading the binary log and stripping out everything with the exception of the GTID. So this works completely real time, so it's quite fast. This process is currently not part of ProxySQL itself, so it's not packaged together, but you can get it on GitHub. There is another repository.
Sorry, René, and what happens if none of these lists have already reached their GTID?
So here you have also the master itself. The master itself has the same process. So the master sent to ProxySQL also his own GTID. So when a client comes and executes a query, when the same client executes a select statement, and the select statement needs to be sent to one of the leaders, ProxySQL will know immediately if the slaves are in sync, and if they're not, it will send traffic to the master.
Thank you.
Okay, so I was saying that it's extremely lightweight, it's also able to auto-restart, so it has the same restart features of ProxySQL, so if for whatever reason it's being killed, we just restart. It is available on GitHub right now, this is the URL of the repository. Currently, from this repository itself, if you run make Ubuntu 18, it will automatically generate the package for Ubuntu 18. This is currently the only platform we are compiling it, but nothing stops you for compiling also on CentOS or any other system. Okay. Now, we introduce also a deep support for Galera. Quick introduction, I'm pretty sure that everybody knows what Galera is. So I'll probably just skip this slide, so move the master setup. If you have used MySQL 1, ProxySQL 1.4, you know that there was also support for group replication. Group replication was done using a table called MySQL group replication, in which group replication Hostgroups. And there is also a table called MySQL Hostgroup replication, that basically where you find the reader host group and the writer host group. This was extended for group replication, having also some more parameters like the maximum number of writers, if the writer should also be a reader. Then for group replication it was max transaction behind, but basically if one of the server was behind the writer by a certain number of transactions, it was taken out from the cluster at ProxySQL level, at the group replication level. And then there were also two more host groups. That it was the backup writer host group, that is basically a host group where all the writers were placed if the number of writers was greater than the maximum number of writers defined. And then the offline host group where all the servers unhealthy were moved there for whatever reason, if they're doing maintenance or just because one of the servers died, they were automatically moved into the offline host group. So the same table structure was basically used for Galera. So we have this table called MySQL Galera Hostgroup, where basically is the columns that I was explaining before. So you have the writer host group, the backup writer host group, the reader host group, offline host group, active. So you can also define if one specific host group set is active or not. The maximum number of writers is also readers, and max transaction defined. This is actually not correct as the name because we just use the same name that we were using for replication, but here in reality what defines is the maximum number of writes that were not applied yet. Here is basically described what I just said. Okay. Now also globally for Galera Cluster, we also have a certain number of global variables that define how frequently health check is being performed on every server, and these variables, MySQL monitor Galera health check interval. So this means that by default, every 5 seconds, every server is checked to verify that it is healthy and it is the state of the server. Every check has also a timeout. So in this case, the timeout for those checks is 800 milliseconds. So if a check fails after 800 milliseconds, it means that the server is unhealthy. Nonetheless, if a server is unhealthy, it's not removed from the cluster immediately, but it will wait up to 3 failure consecutive timeouts before removing the server. Of course, if the checks clearly fails, like if the server is down, the server is removed immediately, but if the checks is timing out, it has to time out 3 times before removing the server. This specific variable that I just mentioned was introduced extremely recently into 0.4. Okay. This was specifically introduced to avoid scenarios in which one check was just failing, so the server was constantly removed and put back. For example, if there was a temporary network glitch or the server was slightly overloaded, so the check was just timing out instead of the server being actually down. Okay, now into 0, we are also adding support for Aurora. It's not completed, it's almost done. We're just waiting some customers to finish their testing to actually proceed with to finish the development of this of the Aurora implementation. So the way it works is there are a few features that are introduced specifically for Aurora. Specifically, it gets information about Aurora from this table. That is a table that Aurora provides to get the status of the cluster. This is the replica host status. So the advantage of here is that ProxySQL doesn't need to figure out which one is the writer and which one is the reader, or which are the healthy node and which are not. But it's Aurora itself that is telling ProxySQL which one they are. So ProxySQL has only to read this table from any of the nodes and figure out what is the status of the cluster. So it automatically is able to detect which one is the writer and which one are the reader. And the fact that reading this table introduces other advantages. Specifically, it is able to perform auto-discovery. So if you have a cluster, Aurora cluster of 3 nodes, and then you switch to 4 nodes, you don't need to configure ProxySQL. There is a 4th node that was introduced, but ProxySQL is able to identify it because it has just to read this information from this table. Also, it becomes easy aware. So it's able to identify which is the latency of every node in Aurora cluster, and this has great advantages if you want to read from a replica that is in the same PZ. So you basically reduce a lot the network round trip to reach any of the replicas because you are already communicating with the local replica. So the latency is way smaller, and of course you also have some economic benefit because you are removing the cost associated with cross-AZ network traffic. Also, it is able to perform. Getting from this table is also able to identify what is the replication log of every replica in Aurora, and is able to monitor replication log with millisecond granularity. This again was a requirement from one of our customers that specifically wanted to not read from replicas if they are lagging more than 20 milliseconds. Okay. This is the table basically. As you can see here, the table structure looks quite similar to the one of Galera. It is similar to the one of Aurora. Sorry, of the one of group replication. So you have the vital host group, prepared host group. You don't have anymore the offline one because it's not needed anymore. You have the active. With regard to Aurora, because there is our discovery and basically all the server has on the same port, on the same port, you also have the port specified in this table. So when a new server is detected, the host name is detected automatically and the port is taken from this table. The endpoint address. So this table doesn't give the full name of the host, but only the initial part of the host name. So the endpoint address is normally added to the host name, so it's able to create the full host name. Then you have maximum lagging millisecond. So any server that is lagging for more than X number of milliseconds is automatically disabled, so no read is being sent to it. The default is quite large. The default is like 10 minutes, but in reality you can lower it to up to 10 milliseconds. Then you also have the check interval in millisecond. Again, it basically says how frequently the interval the check needs to be performed. By default is 1 second, but you can lower it down up to 100 milliseconds. And then you probably have to tune also the check timeout. Again, by default is quite high, but if you want to have these features to read, to send traffic to a reader only the replication lag is very small, you have to basically lower a lot the check interval millisecond and the check timeout millisecond. So basically, you are checking the status of every replica very frequently. Also, you have writer is also reader. So basically, what this means is that when a failover happened, if the replica that had now has become the new writer, it has also to process save statement or not. Yes.
For rotating the log file, like you had a max size approach where like other like daemons are more using like rotate functions to like trigger or rotate, unlog rotate or something like that. Any reason why you went one way and not the other?
Well, in MySQL Binlog, how you do it? You don't use an external tool to rotate. You are not actually rotating, it's MySQL Binlog that is
okay, so
the same approach is being done here.
But the error log is not rotated in MySQL. So you decided to go with like a binlog approach.
Yes, and the general log in ProxySQL use the same approach. So you define the general file name, query log, and then it has those progressive numbers that change over time. And of course, as in MySQL, there is a way of flashing the current log and create a new one with this ProxySQL flash logs. So every time you execute this command in the admin, it will close the current one, no matter what is the current size, and it will open a new one.
So if the default is an empty string, what's the name?
It means it's not generating any log.
Okay.
Empty string basically means that the feature is disabled.
And can you control what you log? For example, successful authentication attempts from the front end?
All those, basically.
You cannot control?
No.
Okay.
It is perhaps feature request. It might make sense.
And the format is?
Just JSON. Only JSON. But I will show you soon how it looks like. So those are basically all the information that you have in the JSON format. So you have the client address, this is because of this, proxy address, so because ProxySQL can listen multiple IP, you also have the address here, and multiple IP and technically also multiple ports. So you also have information about the event, when it happens. The when happens in two formats, one human readable and the other one is an epoch time in millisecond. And then you also have an element called SSL, basically specify if the client connected using SSL or not. And then you also have the schema name, what is the user, of course, what is the thread ID that was assigned to the specific client. This is also useful if you want to track when the client then is connected. When was created the session. This is only relevant to when the session is disconnected because otherwise it's the current timestamp. Duration, again, this is relevant only when a client will disconnect, so it can tell you that the client is connected after a few milliseconds or after hours, so you have this information here. And again, for when the client disconnects, you also have this extra information that basically specify where in the code the client is connected. So it basically gives you a reason why the client session was terminated. Okay, so here are the events. Client connect OK, connect errors. Well, there's, I think, self-explanatory what they mean. So when the client connects and when it disconnects. And this for the MySQL module, and this is for the admin module. Again, here in this case the events are less, and the prefaces, the prefixes, the name of the module. So here is MySQL, while here is admin. So you are easily able to identify on which module this event was generated. Here there is an example of how it looks like, of how an entry looks like. In this case, what we have is that a client using this IP tried to connect. It failed, so you have an admin connect error. Didn't specify any schema name, was not using SSL. It was given a thread ID 2, and the thread was not verified, so just a normal session, an internet session ID, and was using the username admin. And this is the time of when this happened. This is in human readable format, while this one is a timestamp in milliseconds.
It's a question. Do you have anything to protect? Well, far from growing, do you have anything to protect from, for example, DOS attack? If the user connects over and over again, you go into. Oh, you have the.
Oh no,
right?
yes, you have the file size, but of course,
That's all
nothing stop a user to create some sort of DOS.
Smoozing.
Yeah. This is instead a successful connection. So you can see the event is now admin connect OK. And this is the main difference in the schema name is made. That's it. The only difference compared to the previous example. So now a different example. This is when the client disconnect. So basically the client are sent a quick command and here instead we have successful connection to the MySQL module. So we have a MySQL client connect OK, username, timestamp, well, they don't use it before. And we also have here the proxy address. So this client connect to this IP endpoint. This is where proxy was listening on. This is when the same user is executing a change DB. So you have MySQL client in DB, in DB. So basically it's just switching the schema. Where this is instead when the client is disconnecting. And as you can see here, we have a MySQL client close. And the relevant things here is this one basically says that the client disconnects after roughly 9 seconds. This is useful if you want to identify how long the client has been connected. And we also have this information here that doesn't give you a lot of information here, but basically, if you check the code, you might try to understand why the client was disconnected. So it was socket closed, or the client was killed, and so on. So from here, you can identify this. Now, JSON support. Okay. So in ProxySQL, JSON support was introduced into tables, start MySQL process list, and start MySQL free connection. This table is new. And the fact that we have JSON support means that you can now extract information from those two tables using functions, specific function for JSON, like JSON extract. So let's show an example. So this is how it looks. Yeah, so basically from this table start MySQL process list, where created equals 0. And of course, this information is not very useful. But okay, basically you also have, you can change the way this expanded, so you can actually read it more easily. So here specifically what it shows that you can have information about auto commit, which one is the current host group, which one is the default schema, the last insert ID. Those are all internal methods which normally are not possible to extract until this version post 2.0.4. And also you have some elements that are expanded further, like backend, client, and connection. Specifically, here we have information about the backend. This is actually an array. So you have, for every backend, you have a connection. It specifies if multiplexing was disabled, if autocommit is on or off, if there was any init, connect, send, and so on. And then if you're using prepare statement, here you also have a lot of information about prepare statement. You also have information about SQL.bin if it is set 0 to 1. So basically those information are available through this new JSON format. And you can basically query for just some of them using JSON extract for query function. Again, then from the element called MySQL, you can have other information about the MySQL structure. So, for example, you can get the char set, which DB is being used, hosting for MySQL version, and all this information. This is likely to be expanded over time, just to be able to extract more information. Here the status, for example, if there is any table that is being locked, if any temporary table was created. So this information are very useful if we try to understand why multiplexing is enabled or not. Let me show you. So here you also have information about, I don't know, how many bytes are being sent, how many bytes are being received, and this information are available for every connection. So all those metrics are exported. Those are more examples. Okay. Now in 2.0.4, we also introduced this new table that is basically giving information about connection.
Sorry, back to the log. What is the impact?
This is not the log.
Huh?
This is not the log.
No, back to the log. When
okay.
You have the, what is the impact of activity in the log?
Well, it really depends on how many connections being created.
Have you seen, saying 1,000 connection and 1,000 connection, you calculate the impact?
No, I didn't calculate it, but I don't expect it to be the level.
Yeah. Okay, sorry.
So we introduced this new table that is basically give information about the connection in the connection port that are currently not in use. So those are the information that are currently available, like file descriptor, if there was the last error, maximum packet size, so all this information that are very low level from the connection. So if you want to troubleshoot something or open a bug report, those information might be very useful. And ProxySQL admin that is using SQLite and now has the ability of using the JSON extract function. So this is basically an example of how to use it. So from this table, that is MySQL free connection, that is basically this one. We can extract specific element. Like here we are extracting the MySQL info. From MySQL info we are extracting server version, and server version is 5724. And we are extracting the number of questions from the statistic. Now this is ordered by. So basically this is the connection that has executed the maximum number of queries. And that is, this case is not many, if I remember correctly. Just 68. Okay, performance improvement. How do I define performance improvement? So we upgrade a lot of internal library, specifically the MySQL connector. Now it's 3.02, before it was 2.3.1. Gmalloc was upgraded to 5.2. This created a lot of improvement in terms of memory utilization. SQLite upgraded to 3.19, and the performance improvement here were considerable, and especially in the amount of functions that are available. We need to config minor things. Performance improvement were quite a lot of performance improvement, specifically as the number of variables has grown, we basically refactor how this function works. So every time a thread needs to get new variables from the main list of variables, it is quite faster. And the stats table has been improved a lot the way they're generated. This is specifically if you have tables that are very large, like millions of rows. For example, if you have collecting statistics from different types of queries, so the code was improved there. Fast forward, well, it was already fast, but into 0 was optimized even further. And then we also introduced this new variables that is everything the final list of. Yes, it says it's finished. Okay. I think there are the last 2 slides or so. So quickly, memory utilization. Gmalloc 5.2 is the main things that improve performance, and we also have automatic vacuum, and also we have these new variables that is able to normalize the amount of information that are stored in the starting SQL digest. And for MySQL 8, the only thing we did to support MySQL 8 was to enable the authentication plugin. So if a MySQL client was connecting using SHA-256 password or caching SHA-2 was not able to work on 1.4, that's it.